Oops. Sorry for being late. Let's start now. Totally forgot about it. So let's write some extra code today. Yeah, so let's take a look at the next problem we should have. So we were at this, where were we? Sort by height thing here, yeah. So some people are standing in a row in a park. There are 3 trees between them, which cannot be moved. Your task is to rearrange the people by their heights in a descending order without moving the trees. So if AI equals to -1, that is occupied by a tree. So basically, yeah. Well, traditionally to sort, we can the sort algorithms are at least big O and log n, and because this is a special type of sort, I'm not particularly sure how we're going to achieve it in O and log n. Well, it is possible. It is possible by simply marking this item here and these -1s as not available and only sort these items. And yeah, that is definitely possible. So the easiest way is to if your data is kinda randomly distributed, which means it is not like almost sorted, or maybe almost sorted is good for quick sort. So there's a way to sort this thing that is called quick sort, which is by its name is just simply the best way to sort easily, to both sort easily and as fast as possible. So how is it? Well, it is. No, I'm not going to look at these in Chinese pictures. Let me take a look. Let's look at this Chinese Wikipedia page and make it English. So yeah, we can look at the sample here. We first pick a pivot, and that is, by picking a pivot, we mean that we choose one of the item to be the middle point, and then swap between, like, this is the range that we are sorting. We choose a pivot, and then we swap everything that is smaller than a pivot to the left and everything that is higher to the right. Wow, there is also another sorting. Yeah. There is also another feature that we always talk about for sorting algorithms, is if it is stable. So in this case, we kinda want it to be stable, because stable, I'm not 100% sure about this, because stable algorithms. I know what stable means, but I'm not sure if stable is a feature or a characteristic we're going to utilize when writing this question. So let's see, because merge sort is stable, because stable means that if there are 2 items in common, then the sequence will not have changed. Like if there is a duplicate. Oh, actually, is there any duplicate in this case? Probably, yeah, because it stayed at non-descending order. But actually, we don't really care about stableness because 150 and 150 are all the same in this case. We care about stableness when they are a second characteristic that are not the characteristic we're sorting, and if there is another one, we care about it. Yeah. So I was thinking that stability will make a difference here because stable algorithms might make us skip these -1 easily, but maybe that's not the case. So I am thinking if we can write it in a quick sort way. I think the answer is definitely yes, because we can just, when we encounter a -1, we treat it as special case. So that would be the purpose, the ultimate target or ultimate goal of this question. But I'm going to, because I'm late today. Sorry about that. So I'm going to first write an easily understandable implementation, which we can improve in the next episode. So let's see. So basically, let me first check if I'm online. I was in a hurry today, so I have not even checked about that. Check for that. So yeah, basically, let's take a look at this 1, 2, 3. So this really basic sorting is based on comparing the neighboring items, and that is actually has a name as bubbleSort or selection sort. I think it's bubbleSort. Yeah. So let's take a look at the bubbleSort visualization. Here it is. Oh, this is not very easily understand. But oh, maybe this one. This is, oh yeah, it's a GIF. So we swap it whenever there is a bigger one. We swap it and then swap it again, and so the worst case complexity of bubbleSort is n squared because we need to swap as at most. We iterate through these n items n times, so it's n times n. In each time we compare the neighboring pairs, which are n+1 pairs, or actually it's n-1 pairs. Sorry. So yeah, let's implement this one in a I don't know, bubbleSort style. So yeah, because this is a mutable list, so basically we return a at the very end of this. So for no int index n a dot indices maybe 0 to a dot length, a dot size -1. Actually, we can write some extension here if we want to. Let's try it then. Writing Kotlin. I'm wondering if inline so we talked about extension last time. I mean this Monday. So let's see if we can write. Yeah, I think we can. So we just function. Why is this open? Why is this open? Interesting. So let's write this function multiple list of integer, and the function name is size. We actually want a property, so it's yeah, like this extension properties. So it's last index. That's exactly what we want here, and it's also why what that motivate me or inspired me to write. So yeah, that's in a dot last index. Let's see if this works. Well, it's an empty for loop. I don't know if that's a warning or an arrow in Kotlin. Oh. Is this property only available after certain version of Kotlin? Unknown. Version support. Yeah, it's unknown. Oh, so yeah, there is already extension support. But let's take a look at this. Oh, it's a val. Oh, so seems like it's working now. Looks great to me. Local extension properties are not allowed. Where should I place it then? Oh, really? Am I? Okay, yeah. It's not in. I'm not actually sure if this is possible for this function, because that is because this is maintained by code signal. Actually, I kinda need this. So yeah, I'm going to upload it. Okay, so it's working. So for index in 0.a.last index, actually we want a.last index -1. So that's the first index of pair. And we need a second index of pair. Is that even correct? I think so. It's going to bubble up, so that would be -2, and this would be first index of pair up to. So with these, it's going to be work like 0, 1. Okay. Let's see. So, we need at most n times to check. Every time, in every iteration, we are certain that the last or the first, it depends on which side do we swap from. The rightmost, yeah, the rightmost will be cleared. So it's actually the rightmost will always be so it's actually last index not sorted, and it would be a dot last index minus 1 down to 0. Is it down to? Down to, yeah. Last index not sorted minus 1. So yeah, we're going to compare the first index of pair and val temp equals to first index of pair. Oh no, it's a of first index of pair, and if so actually this is hard, this is tough. We're not going to swap if the left value is minus 1, but so second index of pair is not var second index of pair is initialized to first index of pair plus 1, and while second index of pair a equals to minus 1, second index of pair with plus, and if second index of pair is larger than a dot last index, then we do a return. Else we check if a of first index of pair is larger than, smaller than, larger than a second index of pair, we swap it. And a second index of pair equals to temp. And I believe that's it. There is no down to, maybe, yeah, uppercase T. Okay, that's 0. And I found an error here. It's not last index, it's last index, not sorted. Where's that return? Oh, what am I doing here? It's break. Index 5 out of bounds at somewhere, and that is definitely somewhere we access the second index of pair, and last index not sorted. Oh, okay. So I need this check here too. But sound unwise though. I think this can be kind of somewhat simplified, I believe. Oh, that's smaller or equal to. Huh. I'm not sorting the very last one, so yeah, that's the reason. Oh. Oh. Um. It's initially first index of pair, and while is smaller than last index of not sorted, and it's equals to, we need this to +1. We need this equal here, there, for sure. But then we are missing another boundary. Might be here or here. Last index not sorted starts from last index. Yeah, no -1 here. And that's it! I hope. Yeah. So that's the answer of this That's a simple answer for this one. And yeah, let's call it a day then, because that's we're running out of time kinda. So you sort by height in 6 minutes. Nice. But I actually need to refine it tomorrow. So okay, that's something I need to expand on. Okay, and yeah, that's everything for today. See you tomorrow, and we're going to improve this tomorrow. Bye bye.